Hello there, creatures of the night, and thank you for tuning in to yet another twisted episode of Marine Mayhem. I am your host, Raven, where I will be your personal guide to the dark abyss of reality. Today's topic is climate change and oceanic geology, when Earth throws a tantrum. Our main topic for today is how climate change has changed significant impacts on ocean geology, altering processes that are crucial to the Earth's climate system. Rising temperatures driven by carbon emissions have profound implications for marine habitats. As temperatures climb, marine habitats face challenges. Coral reefs are very vulnerable to thermal stress, which has led to widespread coral bleaching events, altering marine life in those areas. Understanding the implications of rising temperatures on marine habitats is essential for developing mitigation and adaptation strategies. In my podcast today, I will discuss sediment dynamics. I will discuss research focused on temperatures and marine habitats, how temperature changes can also influence sediment dynamics, species interactions, and ecosystem resilience. I will also highlight the importance of building coastal resilience, go over these studies that I have read and I think are very important for our topic for today. The first study goes into detail about the impact of environmental stressors on coral reefs, physiology and mortality risk, focusing on lipid and chlorophyll A concentrations. The experimental time for this was about 42 days, where coral lipids and chlorophyll A concentrations followed each other in a decline during the acclimation phase. As coral lipid levels declined, so did chlorophyll A concentrations. The study findings also highlight that high sediment loads were found to alleviate some stress that was caused by the elevated temperatures and light. This suggests that geological processes may actually influence sedimentation patterns and plays a role in coral reef resilience. The depletion of the lipid reservations also shows the importance of nutrient availability in coral survival. This source is particularly important as it shows oceanic geology and how that may affect our water quality and nutrient distribution. Understanding these interactions can help us better understand the effects of climate change on coral reefs and their ability to adapt or recover from such stressors. The second study is actually a journal that was published called Climate Change, Coral Bleaching, and the Future of the World is Coral Reefs. This highlighted the role of the symbiotic relationship between the coral and the zooanthely. Corals flourish in rather specific temperatures and light ranges. Some factors like sedimentation, pollution, and high temperatures pose a threat to coral reefs. The degradation of coral reefs has significant implications for our ocean's geology, including loss of habitat, changes in sediment dynamics, and altered biogeochemical cycles. The ongoing decline of coral reefs not only threatens our marine biodiversity and coastal protection, but also impacts our understanding of historical climate changes. Now that I have introduced today's topic, I will have callers call in and ask me your burning questions. Let's take our first caller. Yes. The paper by Weston Jr. made in 2000. Imagine corals as fish in a giant ocean bathtub. When it gets too hot outside, the water tends to heat up, sort of like when we get a fever. When the ice cores were pulled up and analyzed, they showed us that there was an increase in CO2 concentrations. And these CO2 concentrations were directly correlated with coral health, that it was declining, of course. You know what? This also reminds me of a paper focused on lipid and chlorophyll A concentrations. It highlights that the high sediment loads were found to alleviate some stress caused by elevated temperatures and light. So what does this all suggest? This suggests that the geological processes may also influence sedimentation patterns and plays a role in coral reef resilience. Man, these corals are stressed out. Great question. When the water gets too warm, corals expel their algae buddies. It's like kicking out your best friend who brings you food and fabulous looks. Without these algae, corals are mainly starved and turning ghostly pale. The importance of this algae relationship is that it gives corals that strong, vibrant hue. This also reminds me of a passage that I read that highlights the sea temperatures have risen about 1 to 2 degrees per century. That's crazy. Based off of the data specifically in the late 90s and El Nino events, It also brings up the point of biodiversity and how much more will be lost if more mass bleaching events continue. Going into further details, the journal mentions that about 24% of fishes caught in developing countries are directly provided by the Great Barrier Reef. The dark chemistry of carbonic acid, turning our oceans into an acidic nightmare. The silent killer CO2 is like a toxic ex who won't stop calling. Elevated CO2 levels mess with fish brains and wreck their neurotransmitter game. Less amounts of carbonate ions that are present means much less coral reefs. Their skeletons are literally crumbling under pressure. It has been on a rapid increase since the Industrial Revolution, which is not as punk as you may think. We are also burning a lot of fossil fuels, and this is causing rapid CO2 emissions. Projections even say that about 0.7 degrees Celsius has changed, and we predict that about another 2 to 4 degrees Celsius will continue to change by the end of 2100. These elevated temperatures have proven to affect these corals by reducing the capacity for oxygen consumption. Some may even say that reproduction may also be affected for the fish that reside in these marine habitats. The overall change to these corals pose a significant threat, especially to some species who rely on the reefs for habitats. According to one of the studies, some fish are highly sensitive to temperature changes much more than others. Take the damselfish, for example. A damsel in distress? No. But a damsel in stress? Yes. These fish are particularly much more resilient than other fish, especially to warm temperatures. However, we cannot expect all of our species to adapt such as these. We may experience more local extinctions if these fish are not forced to find new habitats and ranges. Perhaps the impacts of rising CO2 levels on coral reef fish may extend even further than we may have realized, such as in physiological stress, effect on behaviors, and sensory functions as well. The article also dives deeply into elevated CO2 levels and how it appears to disrupt neurotransmitter functions in the brain of a fish. This is your host Raven signing off for today. Thank you so much to our viewers for tuning in to yet another episode of Marine Mayhem.